Good to go. We can get started.
Great.
Awesome. Hello, everyone. I am Soraya Edwards, the Marketing and Communication Specialist here from New Buildings Institute. And other than our speakers, welcome to our all electric commercial kitchens. Other than our speakers, all mics will be on mute, and I would like to pinpoint a couple of items on your dashboard. We ask that you limit your questions to our chat box and Q&A. You will be able to share your thoughts by chatting to everyone. And you can also click on the chat again to hide chats if you find it too distracting, as well as in the Q&A section, there will be time for questions near the end of our time together. Please add your questions in the Q&A section so that we can find them easily and respond. I will be on hand in case you have any technical issues and need support. And with that, I would like to now pass the microphone back to Joe.
Great. Thank you so much, Soraya. Welcome, everybody. Welcome to our webinar today on all electric commercial kitchens. Great to be on with you. We will introduce our panelists in just a second. I'm Joe Wachunas, project manager at NBI. And we are partnering on today's webinar with the CEDA program, the California Energy Design Assistance Program, which promotes the electrification and decarbonization of new building construction or major renovations. CEDA works in collaboration with project teams to reduce energy demand, consumption, and carbon emissions. So why participate in CEDA? Well, you get to receive complimentary custom decarbonization analysis. You gain analysis of energy costs and paybacks, and perhaps most importantly, you get financial incentives to help offset the costs of decarbonization measures. Some of these financial incentives are up to $2,800 in design team incentives to help busy design teams incorporate decarbonization measures into buildings. And then, of course, there's the energy savings incentives. You can see some of them on the screen, and we will send these slides out afterwards. But if you have any questions, please reach out to Jeff Glover or Tina Hendricks. You can see their contact information on the screen and participate in this great program. So huge thanks to CEDA for being on today's, or helping promote today's webinar. I'd like to now turn it over to my colleague, Liepa Bracciolite, to introduce what we're talking about today and our panelists. Go ahead, Liepa.
Thanks, Joe. In this webinar, we'll answer questions that you may have on electric commercial kitchens, such as what exactly is an all-electric versus an electric-ready commercial kitchen? How do you design and build one? And what are the challenges of building it? We will also have one of our speakers give an overview of what the state of Pennsylvania is doing to incentivize the electrification of commercial kitchens. And later we'll talk about the multiple benefits of them, including health and safety, air quality, comfort, and among several others. We'll showcase one case study of an electric kitchen, and we will debunk some of the most common myths around electric kitchens. Next slide. So why are we focusing on commercial kitchen electrification in the first place? Electric commercial kitchen technology is well established and has been used by cooks and chefs for years. Electrifying kitchens enables food service locations to avoid the use of fossil fuels and significantly reduce greenhouse gas emissions and help mitigate climate change. The electrical grid in California and elsewhere is continuously getting cleaner, which strengthens the need to electrify our buildings, including kitchens, in order to reach our climate goals. Electrifying commercial kitchens also has the benefit of improving worker thermal comfort, reducing heating, ventilation, and air conditioning loads, and even improving worker safety. Wherever kitchens are not fully ready for electrification now, incorporating electrification readiness in new construction can prevent lots of costs in the future. But are these commercial electric kitchens ready for prime time? How much do they cost? How do builders and designers go about building and retrofitting commercial kitchens? We'll be exploring all these questions and more in the next hour and a half, so stay tuned. Next slide. So we have three great experts on our panel today. First, we'll be hearing from Richard Young. He's the Director of Outreach at Frontier Energy Food Service Technology Center, an unbiased commercial food service research and training facility. We'll also hear from Chef Christopher Galarza on our panel, who is the founder and culinary sustainability consultant for Forward Dining Solutions, LLC, and works with clients to create kitchens that promote healthy, efficient, and equitable working conditions. In addition, we'll have Heidi Kunsch, who serves as an environmental group manager at Pennsylvania's Department of Environmental Protection, where she manages and oversees education and outreach, as well as financial incentive programs for high performance green buildings and clean transportation. Next slide. And I'll give it off to our next speaker.
Yeah, Richard, thanks so much.
All righty, and I know you're going to let me know if you can't see my screen. And I'm going to get
Great.
everything set up here. And hey, everybody, welcome. We'll have a little fun today. I've got decades of experience. I'm going to condense it down to about 20 minutes. I encourage you to ask some questions, and I'm try to keep some time at the end as well for questions. But I'm going to give you some knowledge, get the brain juices flowing, and see what we can do here. So I'm Richard Young. I work at this cool place called the Frontier Energy Food Service Technology Center. I have been there going on 35 years. I enjoy it every day as a new adventure, and work never slows down. I want to show you just proof here. There's a photo of me back in 1992 doing research on gas and electric range tops in our lab, and then a more recent photo of me doing some induction demos. So been at this a while. That's about a 31-year gap between those two photos. Just want to point out, I like to, when I teach college classes and stuff, like to show this photo and point out that we need to get to zero net carbon in about 27 years. I can tell you those years go by fast. So you can measure, right there what we need to do. This is a disclaimer. Today, my time is being paid for with public dollars through the CPUC and PG&E. This is a disclaimer that says we're unbiased. Everything we tell you is true to the best of our knowledge. And this is the funding mechanism. Public dollars that come to the California Public Utilities Commission is administered by PG&E, pays for our workforce education and training. I'm immensely grateful. That's how we get all this good information out. Also, because I work in utility and I'm the safety guy also in our lab, like to start with a really quick safety message. And this is food safety. It's summertime, it's hot everywhere. Please refrigerate your food. I just came back from an environmental health conference. It's astounding how many people get sick from food. Don't skip that step. Keep it in that fridge, okay? So now let's get into the meat of it. Electrification means all electric kitchens. Let's talk about this stuff, right? And there's going to be some challenges for commercial food service, which has traditionally been a mixed fuel with mostly leaning towards gas appliances on your cook line. The first thing that everybody says is the challenge is behavior change. Yes, it's going to require some behavior change. And, there's the, oh my God, the chefs will never do this, or the kitchens will never work. I think the behavior change is actually the smallest challenge that we're running into. And this comes from personal experience, talking to people, seeing projects. Chef Chris will talk about this some. If you give people in a kitchen good equipment and good training, all of that goes away. Our biggest challenge is the differential in cost in most places in the United States between electricity and natural gas. Electricity is a more expensive fuel than natural gas. Now, in situations where we have universities, like the early adopters, right? Universities, hotels, hospitals, school districts, places where the overall infrastructure cost is much bigger than the energy bill, that's not such a big deal. I'm mostly concerned about this differential in fuel cost when we start talking about the mom and pops, the small independent operators, and most of the industry, the restaurant industry, not the institutional side, most of the restaurant industry is, really independent. Even the McDonald's down the street is owned by some franchisee who essentially is an independent operator. So I mentioned this right up on the front end because as we get to the end of my presentation, I'm going to talk about what we need to do to try and balance out these costs. It really comes down to looking at more than swapping appliances. It really comes down to building the efficient kitchen of the future. We try to make up for these differentials with efficiency, right? With reducing fuel costs. Now, one of the things that we were talking about in the intro is what is the difference between an all-electric restaurant and an electric ready, right? And I want to come back and talk about in the frame of like codes, because that's really one of the things that's driving codes and standards are driving kitchen electrification. We have not moved quickly enough to reduce our carbon. So it was actually at an NBI conference in about 2014 when everybody said, hey, you're going to start to see more codes and standards. That's what we're seeing. And I'm thinking, one of the things that might be happening in the codes and standards world, and I've seen examples of this as well, there's some out there, is where a municipality says, we want you to be all electric, but we're going to do a carve out so that you can put some gas lines in. And in the short term, you can still run gas appliances, but we want the building to be built so that down the road, however many years, we say everything needs to be all electric. You can pull those appliances out and put in electric appliances. So that's what an electric ready restaurant would be. It's set up so it has all the infrastructure that you could run all electric, but in the short term, you could still run natural gas appliances, as opposed to an all electric kitchen that is right now today, pull the switch, all electric. So that's that little distinction. We could do hours on the codes and standards, and that's another presentation. We'll do that one further on. Let's keep on the flow here, talking about overcoming the challenges right now, because once again, there's this notion that the electric kitchen is not possible or it won't function. And in reality, most of the appliances in a commercial kitchen right now today could be electric or gas, and the people in the kitchen would not know. When you start talking about things like griddles, fryers, convection ovens, steamers, double-sided griddles, combination ovens, steam jackety kettles, all of these are pieces of equipment where manufacturers make equivalent versions of gas and electric right now. So that's, other good news in overcoming the challenges. There have been electric kitchens for decades in various situations. So this is not something that's super alien. Another one of the trends that's kind of helping with this notion of kitchen electrification is that an awful lot of the new equipment that is available is already moving in that direction, because it tends to be these small, what we call rapid cook or high-speed ovens. If you've gone to the Starbucks, you've seen that TurboChef oven over there that's warming up your breakfast sandwich, which I love those breakfast sandwiches. And those are all electric, right? So in the effort to create more modern, fast and programmable kitchens and get more production in a smaller space, we're already moving in this direction. There are new tools that tend to be all electric anyway. So, and then another one of the tools that is going to help us overcome the challenge is induction cooking. Induction cooking is a great technology. If this technology were not available, I'd be very concerned about moving towards the all electric kitchen. But induction is a technology that's been around. I've been testing it, promoting it, talking about it for 25 years. It's a well-developed technology. And let's just touch really briefly on how induction works. I assume a lot of you already know this, so I'm just going to touch on it really quickly for those who don't. What we have is a coil that sits underneath a plate, and we're running current through that coil, and that creates for us this electromagnetic field that sits up above that glass plate, right up above the cooking surface. When I put my cookware, and the way you know that the cookware works is you go pull a magnet off the fridge. If it sticks to that cookware, it will work. It has it's ferrous, it's magnetic. I put the cookware in that electromagnetic field, and the field starts exciting the molecules, and lo and behold, I have heating in the pot. The heat of the pot of the cookware is what heats the food. It's a very efficient process. And in this photo, you can see there's my copper coil, right? And one of the other cool things is, because I have a temperature sensor that's coupled to the top of the cooktop, which is this one right here, I'm always getting feedback on the temperature. So I have a lot of precision and the ability to do some cool things like programming. And, if I want to, I like to make lemon curd. I think I'm going to do it tonight. I pull out my induction cooktop. I set it on 180 degrees. It's not going to go hotter than that. And that's the magic temperature that I need. So there's some benefits there. Now, I want to take just a moment and explain this next slide, okay? What you're looking at is a couple of infrared shots. The one on the left is the induction cooktop, and the one on the right is my gas cooktop. And let's talk efficiency for a moment. Because that energy that I put into the induction cooktop is directed very precisely into the cookware itself, I have a very high efficiency. So if, let's say I buy $1 worth of energy to make my lemon curd tonight, 85 cents on that dollar is going to go into that cookware. And you can actually see, when you look at it, you can see that electromagnetic field, right? And everything around the cookware is cool. So that's high efficiency. I don't have a lot of waste heat. Now I want to compare that to the gas range. If I bought $1 worth of energy, about 35 cents will make it into actually the food that I'm cooking, my lemon curd in this example, and about 65 cents goes out as waste heat in the kitchen. And once again, from the infrared, you can actually see that we're doing a lot of heating around the cookware. More heat is escaping around into the environment and into the cooktop than is actually getting into the food that I'm cooking. So that's that efficiency notion, and one reason that in the big picture, and this is rare, usually electric appliances cost more to operate than a gas appliance, but we've done a couple of studies showing that an induction cooktop cost about the same to operate as the gas cooktop. There's no change in your OpEx, and it's because of this radical difference in efficiency. Okay, now let's talk about that once for a moment about how that affects kitchen comfort. So a little science moment here on the ways that we create and transfer heat. There are three kinds of heat. Conduction is what happens when two things touch. So that's my burgers there touching the broiler. Convection is the heat that's rising up. We capture most of that in our exhaust hood. And what's left over is radiation. That's what you feel when you sit next to a window on a sunny day. You can actually see it sort of reflecting off of the technician's head here, right, as he cooked. Radiation heats the kitchen. It is uncomfortable, makes the kitchen hot. So we did some research in our laboratory, and what we're looking at over here is what we call the radiant heat gain to space, and it's measured in BTU per hour. So to make this like human, I just want to say that 12,000 BTU per hour is 1 ton of air conditioning. We've all heard that bandied about, oh, I need a 5-ton unit on the roof. Okay, so 12,000 BTU per hour is a ton of air conditioning. And so what we did was the blue bars are where we're taking a gas range top. We put some pots on it and we bring them to boil uncovered. And you can see that 6 pots on a gas range top boiling uncovered is requiring a little more than half a ton of air conditioning to deal with that radiant heat that's actually coming out into the kitchen. The induction has 0. Same thing when we do 3 pots, we got about a 1/4 ton. The induction is 0. You know, when I just turn on all the burners, which I have seen in that fancy Italian restaurant, turn on all the burners, they're all going, 6 burners on, nothing on them yet. You know, they're just heating it up so they can saute. That's a ton of air conditioning that we're requiring to remove that radiant heat. And same thing, 3 burners, a half a ton. But once again, 0 radiant heat coming off the induction cooktops. So the induction cooktop has that potential to give you a cooler kitchen. That's not the case with every piece of electric and gas equipment. An electric griddle and a gas griddle produce about the same amount of radiant heat into the space. But for induction cooktops, there will be no more notion of slaving over the hot stove because that radiant heat disappears. A couple of other benefits: no flame means less fire and burn risk. Precise controls can, as I mentioned, can reduce your labor and your food waste. And then, of course, it's easy to clean the tops on induction cooktops. You just wipe those babies down. Our chef loves that. he thinks that's great. One of the challenges people have talked about is getting, honoring Asian cooking and having full-size induction wok cooktops. I myself absolutely love Asian food. It's my favorite food out there. I do not want anything to hurt all of my favorite restaurants. But induction is used widely in Asia right now today. And what you're looking at is a photo of a couple of full-size induction cooktops that are actually in our facility out in San Ramon right now. And the one on the right side is the one, if you've looked up the Microsoft project that Chef Chris worked on, this is the induction wok that they use there. So full-size induction is there. Challenge is that they're not on the street. If you walk down to the restaurant supply to buy it today, you won't find one. They're hard to get. You can find the small ones. You can see the small ones up here, but the big ones are still limited. So as an industry, we need to work together to create that market and push that forward. There's several manufacturers working on it. That's also good news. I went to the restaurant show this year. And, you know, I would just want to show you, these are all photos of various induction cooktops, that full-size induction cooktops that manufacturers are working on. So when it comes down to manufacturers who traditionally are producing gas equipment, they now see that they need to be playing in the induction market. So they are also working on their induction equipment, which I think is cool. Add some excitement. This is a photo in our demo room, once again, where we have 3 different formats of full-size induction cooktop. So it's not just these tabletop units that everybody's seen in the past. You know, we're now talking about full-on equipment, and I'll show you a couple of pictures of that. And before I move on, I just want to point out that the biggest market at the moment, the place where the manufacturers are selling the most equipment, is in warming and holding. And it really works well, you know, in hotel buffets. These little induction soup warmers here, they cut the energy use in half over a regular electric soup warmer, and they save the food quality because they have some smarts, and it's adjusting the temperature as the food is pulled out of the soup warmer. So there's efficiency gains, there's performance gains. You get, you know, things like this are great. You get these clean surfaces, so there's design gains. It's all very doable. Now, one reason I moved so fast through all of this is that there is a great 1-hour course on all of what I've just talked about that goes deeper. It's online. Here is the link. And by the way, I think somebody in the chat had mentioned the notion of when you get the slides, we're sending you out PDFs of all the slides. So you will have all this information. You don't have to take notes as fast as I talk, because that would be super hard. I urge you to take this class. It's a great deep dive. And if you are a PG&E customer, we have a PG&E induction cooktop loaner program, and we will mail you a small tabletop unit. You can play with it, keep it for a couple of weeks, and then you just mail it right back to us. It's no cost. Once again, in the handouts, there's the QR code, but you must be a PG&E customer. If you're not, then check around, because other utilities like SoCal Edison, Sonoma Clean Power, East Bay Community Energy, they all have various levels of induction loaner programs. And I know there are other programs in the US. Get one of these things, borrow it, play around with it. It's a cool technology. I think you'll like it. So now let's move from a specific piece of equipment and let's start talking a little bit bigger picture, okay? Anybody who's in the commercial food service world, every conference I go to, everything, you know, that is a discussion point is going to talk about some of these big drivers. One of the biggest drivers in commercial food service absolutely is real estate costs. That has been crushing restaurants, particularly when you get into California and, you know, New York, high cost urban areas. Real estate is really, really tough. So people need to do more food production in less space in order to stay in business. Waste reduction is another one, particularly in states like California, that now everything, you know, all your food waste has to be composted out here, right? We can't just throw stuff away. And of course, that's a national effort as well to try and reduce our food waste, because it's nuts that we throw away so much of what we produce. Labor shortage is the #1 complaint I hear from everybody across the board. I don't care if it's a school district or a chain restaurant. Finding people to work in kitchens is hard. There's not enough people. And then, of course, decarbonization is what we're talking about today. And that's the big unknown that people are trying to get their hands around. What does that mean? How do we start, you know, because commercial food service is the most energy intensive, which means it's the most carbon intensive commercial end use out there. So decarbonization is a big deal. We need to move. We're like 10 times more carbon intensive than the shoe store or the big box retail down the street, right? So what's the vision? How do we do this? Well, we need to move towards what we call the kitchen of the future. So let's explain this for a moment. The traditional kitchen tends to have, you know, sort of one of everything, which is great back in the day when we had infinite real estate and lots of money. We could do that, right? And we build a kitchen that just had one of everything we needed, maybe 2 of everything we needed. And we put a bunch of employees in there, and we'd have a great big exhaust hood. And yeah, if I needed this, you know, second oven every once in a while, it was there for me. But half the time I wasn't using it, you know, this kind of stuff, right? Not much flexibility in the equipment. You know, this stock pot range did one thing. This fryer did one thing, kind of deal, right? So that all worked in the good old days. That was fine. What we need to do now is move to a kitchen that's much smaller. Remember, we've got the real estate issues, right? So what if we can do that same production in 16 feet instead of 24 feet? That lowers our hood size. It's less space that we need to rent or purchase. Also, what if we put in equipment that is much more flexible, like those Rapid ovens or combination ovens, which is a really, really killer app, or these nowadays we're seeing a lot of very high-tech braising pans, right? Multi-function pans. What if we use that kind of stuff and cool technologies like blast chillers? And of course, we've got our induction. You know, if we start to use things that are much more flexible, we can reduce the size, and that means we can get more work done with less labor. And you'll notice that I put a nice little chef hat on here, because in my world, what I want to see is one person who's getting paid a really good professional wage instead of two people who are getting, you know, minimum wage, a non-living wage. And the whole industry wants that. So when I talk about all of these shifts, all of this stuff is kind of happening anyway, right? As we move towards this electric kitchen, we're already also stressing all of this. And once again, if you're in a situation where you've got an existing building, you don't have infrastructure, but you're doing a retrofit, all of this applies to gas equipment as well. You know, if it's impossible to go electric, the next best thing you can do is put in the most efficient gas equipment you can, because you'll cut your carbon in half right now today. So all of these pieces of equipment, you know, with the exception of the induction cooktop, all of those standard pieces of equipment are gas or electric. So that's your second level. I'm an engineer. I'm really practical. I want to see carbon cutting, you know, as fast as possible. So it's funny, you know, once again, we talk about this kitchen of the future, and we went to the restaurant show, and here's Chef Mark and Jamal, two of my colleagues, two of my buddies. And what did we see? You know, design the future commercial kitchen right there. We've been preaching this stuff for a decade, and now and this was the center booth in this restaurant show. This was the big equipment show right in the center. This is the biggest manufacturer and the biggest booth. So we felt a little good about that. And then we're really promoting all the technologies I was just talking about. Here's another shot of our facility. This could be that kitchen of the future. I've got a combi oven. I've got the braising pan, tilting skillet kind of thing, my induction cooktop, and way over here on the right, kind of hidden, I actually have an air fryer over there. But you can do a tremendous amount of production, and you can program this stuff and do it over different time periods. A couple of other kitchens. This is a high-tech facility. You can see a couple of these full-size induction cooktops in there. And this one down on the end is a griddle / plancha. We've got a whole bank of combination ovens. They are the killer app, right? Combination ovens are great. They should be in every kitchen, big or small. Here we've got more of like a cook to order line. Same thing over here. You're seeing we've got the induction. In this case, it's a griddle, and it's a groove griddle, so you can get some char marks. We've got our cooktop. Somebody talked about the electric ovens, right? The Pizza Master electric ovens are actually being purchased by a lot of operators, and not just this brand, but other brands. But this one sometimes gets called out. They're kind of early adopters. They're getting adopted by a lot of operators, even folks who are not doing it because they're going all electric. They're purchasing these electric ovens because they heat up quickly. You don't have to sort of keep the heat on them, you know, 24/7 to keep the stones up. There's a faster response time there. So, you know, once again, there can be a win-win just based on the performance of the equipment. You don't even have to be thinking about, you know, am I trying to push electrons instead of gas? And once again, that's a win-win. Here's another kitchen, same thing. I've got my induction cooktop, a really high efficiency griddle, and some more combi ovens and some refrigeration. And another cool thing is when you start going with things like, you know, countertop equipment, this countertop electric equipment, you can also put these refrigerated bases underneath, which saves you some legwork. Okay, let's start to tie all of this stuff together into what really needs to happen. As I mentioned at the front end, electricity is a more expensive fuel than natural gas. For the mom and pops, that is a tough sell. They are already barely making it. There's a restaurant down the street from me that is beloved. It's a full service restaurant. They have pretty decent to high ticket prices. They have good customer base, and they are just always hanging on by their fingernails. And they are not unique, right? It is an extremely tough industry for independent people. So we need to be thinking about how we level out those costs and all the other benefits we can get as well. If we can level out the energy costs, then hey, and also lower our labor cost and make things easier to clean, all of this kind of stuff, then we can try to actually make the all electric kitchen really cost effective for people. So as I said, core components, smart, high-tech equipment, the combination ovens, the rapid cook ovens, high efficiency, high efficiency, high efficiency. If you're purchasing something gas or electric, make sure you're going for the high efficiency equipment. I'll give you a resource to find that list at the end. But cooking, holding, refrigeration, sanitation, that's your dish machines. Don't buy crappy, low efficient equipment, electric or gas. Don't do it. Buy the high efficiency stuff. Safer and faster equipment, that helps to cut our labor and off-peak production, right? If we can get things like the combination ovens and cook chill, blast chillers, we can start to move some of this stuff, program these ovens and do stuff in off-peak hours. That helps us with our labor costs. That helps to balance out that energy cost. Demand controlled kitchen ventilation is a great technology that can cut your energy cost in half for your kitchen exhaust hoods, which is a big cost. So everywhere that demand controlled kitchen ventilation can be used, it should be used. And advanced plumbing design with heat pump water heaters, and I'm just going to hold that one for a minute because I got a couple slides on this. The plumbing of the future. I know we're excited about that. And then also, going all electric means we're going to start moving over to heat pump space heating. So let's talk about the plumbing for a minute. Okay, so today's plumbing, and you see I used a very sort of crusty font there to talk about this. What we tend to do now is really 100-year-old kind of design, or older, right? We have some water heaters there. We run a great big loop, that goes way all around the whole facility. By the way, this is a diagram of a restaurant where we actually went in and took the whole thing apart and redid the plumbing. But what happens when you have a great big loop like that, that's rolling around, is that by the time the water gets out here to the end, it's not at the right temperature. It takes forever to get water there. You get poor performance. You waste a lot of heat in your pipes because you're recirculating this water all the time. So this is not a great design, and it puts a lot of burden on the water heater. And the problem is a heat pump water heater is not the kind of device that can run full tilt for hours. It can give you a big load of water in that first hour, and then its ability to produce water goes down. Okay, so what we need to do if we're going to, now the payback is a heat pump water heater is a really inexpensive way to make water. It is super duper efficient, but we need to think about our design, because we can't put this great big load on our heat pump water heater and have it work. So this is what you do. Okay, this is golden stuff. We need to take as many of the in-use sources off of that water heater as we possibly can, and just use the water in our centralized heat pump water heater for the things right next to it that are most important. So in this instance now, here's my water heater, and I'm going to use that hot water for my mop sink and for my 3-compartment sink and some hand sinks, right, that are close by. I now have a small recirculation loop. I'm not losing as much heat. And I've taken all of these other loads like the bar sink and these other hand sinks, and most importantly, my dish machine, I have taken all of those off of the hot water system. They are all now running only cold water lines, because these guys have instantaneous water heaters, okay? And this is a heat recovery dish machine, which can run on a cold water line. You run cold water to it, it starts to grab that. It's got its own little booster heater inside, and then it captures waste heat. And once you've run a couple of loads, it can operate completely off of a cold water line. That's the plumbing of the future, right? This is this whole notion of holistic design. Now, I've listed all this stuff out in your handout, so you can run over to your MEPs and give them this. It's hot water system, designing a distributed generation system using water efficient equipment, pipe insulation, demand recirculation, et cetera, et cetera. If you're like, Richard, where do I find out more about this stuff? You go to caenergywise.com. Okay, that's our California website. It's open to everybody. There's no login, no nothing. You get there, you go to places like resources. That's where you're going to find these design guides that are going to tell you how to do the plumbing of the future. They're going to tell you how to do demand control ventilation. You're also going to find rebates there. The rebate list on the California site is the master list for the entire United States. If you're in a place that doesn't have a rebate, use that list to still buy your energy efficient equipment. Once again, and that's gas or electric. If you are in California, get those rebates. They are very generous. And the instant rebates program is in about another, 12 states total. So take advantage of it. Look for it. There's also classes on there. Everything you could possibly want is on this website. So it's a huge library. Take advantage of it. It's public information. I have one favor for you. It would be great if you could grab this QR code and take a really short little survey for me. It just helps us develop materials. You could say, hey, Richard, next time you speak, I'd love to know more about demand control ventilation or something like that. This is you, the public, telling us what you'd like. So grab that QR code. And with that, I'm going to say thanks. And let's look for questions and all this kind of good stuff. So any questions rolling in? Joe, do you want to moderate for me?
Lots of questions. Yeah, absolutely. And I'm really glad you put the California Energy Wise site up. A lot of the questions were looking for calculation assistance. And I saw that there was a calculator on that site, and then lists comparing energy consumption on different kitchen appliances and different fuel types. So it sounds like folks can go to that California Energy Wise and get all the information.
I did a lot of that, yeah. And if you have other questions or you got a project or something, you can always, my email's there, you can ping me. We do a lot of projects for folks. You know, a lot of this stuff is not necessarily cookie cutter, and people come to us and we do the energy modeling for them. I know it's not completely simple, so we like that stuff. Other questions? What else do we have out
Perfect.
there?
Yeah. Well, we'll do a couple follow-up now, and then we'll do a larger Q&A at the end. But I did want to just ask about the electric cooking being more expensive. You mentioned that induction cooking, because it's more efficient, is almost cost comparable to the gas cooking. But is that a reflection of California's electricity prices, or would you expect to find that nationally more expensive on the electric?
Once again, it really depends where you are, but I can say, California, and particularly where we live, has about the most expensive electricity prices out there. We're sort of hitting nosebleed territory. And so, if you've got parity where we are in California, then when you get down to the Southeast, where a lot of electricity is pretty low cost, or up into Washington State where it's low cost, then the induction cooktop could actually cost you less to operate than a gas range. Right. But I like to use the rule of thumb that it's about the same operating cost for those two items, which is great. Right. That means now the induction cooktop is going to cost you more on the capital cost side. Right. It's a more expensive upfront cost piece of equipment because it's got technology built into it. But on the OpEx side, they're about the same.
Thanks, Richard. Liepa, any quick questions before we turn it over to Heidi? Yep, I think
you hear me okay now?
Yeah.
Okay. There was a very quick question here at the end. Are there any applications that can be electrified right now?
Well, that's a great question, and it's a bit of a great question. Yeah. If you've got a facility that has a big enough panel in it right now that could actually cover any new electric equipment you wanted to put into it. Yeah, you can pull out a piece of gas equipment that's in there now and go roll in and replace it with a piece of electric equipment if you have that infrastructure there. Like the biggest challenge with existing kitchens is that we've already filled up most of our panels, and we don't have a lot of breaker room to say go put in a brand new all electric oven or all electric griddle or whatever, that kind of thing. And so that's the infrastructure challenge. But yeah, there are plenty of people that are already doing this, and some restaurants that are making that transition. But it's more rare to see existing kitchens doing it. It's typically new construction is where we see it.
Yeah, that panel upsizing question did come in as well. So we'll put a pin in that and talk more at the end about what that looks like with the retrofit panel upsize. Thanks so much, Richard, for that amazing presentation. Let's kick it over to Heidi for a look at one state that's incentivizing all electric commercial kitchens. Go ahead, Heidi.
Good afternoon, everyone. So I'm Heidi. I'm with the Pennsylvania Department of Environmental Protection's Energy Programs Office. In the eyes of the U.S. Department of Energy, my office is considered the state energy office. We receive annual funding from U.S. Department of Energy to carry out a myriad of energy programs throughout the Commonwealth, one of which is our CHECK program that I'm going to be presenting on today. So this program is fully funded by U.S. Department of Energy state energy program dollars. So CHECK stands for Cooking and Healthy Electrified Commercial Kitchens. We hope you'll check it out later. I'll share our CHECK webpage. We like to do some fun puns with our program. So the Energy Programs Office, like I said, we are the state energy office in Pennsylvania, housed at our Department of Environmental Protection. These are our mission statements here. I won't read them for you, but our climate office in Pennsylvania is also housed in our state energy office. And we also focus on energy assurance, renewable energy, energy efficiency, and alternative vehicles and alternative fueled vehicles, or alternative fuels as well. So a whole host of programs that we offer. And we do a lot of education and outreach, technical assistance, and we also offer financial incentive programs. So why electrification? Why did Pennsylvania choose to start promoting commercial kitchen electrification? This table is from our 2021 Pennsylvania Climate Action Plan, and it shows the greenhouse gas reduction strategies that are really going to make the most impact in our particular state based on our greenhouse gas inventory. Industrial emissions are our greatest source in the Commonwealth. So you can see a carbon emissions-free grid is number one, but number 4 on the list is incentivizing building electrification. Because as NBI said during the intro today, as our grid gets cleaner and cleaner, it's all the more important that we start to electrify our buildings. So the CHECK program is not only an education program, it's also a rebate program. And it's also a pilot program. We opened in October of 2022, and we started round 2 of our funding on July 5th of this year. It's still considered a pilot because we actually just opened the program on July 5th to restaurants. So we're still trying to gauge the appetite, unintended, for commercial kitchen electrification here in Pennsylvania. So far, there hasn't been a ton of appetite, I'll be honest, and my last slide covers that, but we're still forging ahead here. So the goal is to help commercial kitchens in Pennsylvania become healthier places to work via energy efficiency and electrification. As Richard just pointed out, efficiency is just as important as electrification. You can't electrify your kitchens and have it using a ton of energy at the same time. So they go hand in hand. We require that folks, in order to apply for our rebate, become educated first. So you either have to attend one of our live webinars or recorded webinars on our webpage featuring Chef Chris Galarza, who's about to present after me, or attending one of Chef Galarza's in-person induction cooking workshops that we've been hosting throughout the state. So Chef Galarza, here's a picture of him there in the background. This is my favorite photo from any of our induction cooking workshops that we've hosted throughout the state. We've done 3 so far this year, and we have 2 more currently scheduled in the summer and hopefully 1 more in the fall. But what I love about this photo, this is at a restaurant that's actually pursuing Living Building Challenge certification in State College called Refarm Cafe that also focuses on regenerative farming practices. And right here, right down the row, are 4 pieces of technology that the CHECK program incentivizes. You've got your induction wok in the foreground, an induction cooktop in the middle, and an induction griddle in the back. And then Chef Galarza is actively pointing out the demand control kitchen ventilation system in this photo and how it actually functions. So Chef is our hired contractor from Forward Dining Solutions, which is based in Pennsylvania. So we have an in-state, nationwide kitchen electrification expert. So we offer the webinars that I mentioned. We have a live session coming up that's geared specifically towards restaurants on August 15th. And then we also have recordings of prior webinars he gave last fall. And then we have some upcoming workshops in the Pittsburgh area, that's Gibsonia, and then State College back at Refarm Cafe. So as for the rebate program itself, we allocated about $150,000 in funding. We have a good chunk of that still remaining. Under round 2, we increased the rebate amount. You can now get a maximum of $8,500 per applicant. They're available on a first come, first served basis with a focus on either nonprofits that service environmental justice communities or are located in environmental justice communities. And the buildings that apply can either be new construction or existing buildings. And you must apply for the rebate prior to purchasing the equipment. It is not a retroactive rebate program. And you can see here the list of eligible applicants. The first 4 listed were eligible in round 1. And as I mentioned, we just opened it up to restaurants on July 5th. So here are our rebate amounts currently and the eligible technologies. So you can see first row, Energy Star certified commercial cooking equipment. And I know Tanya was in the chat earlier. I believe she's with EPA and Energy Star, sharing a list of where you can find all the equipment that carries the Energy Star label. That qualifies for a $4,000 max rebate. Demand control kitchen ventilation and induction cooking equipment gets the max rebate. And then we're also, for any of those projects that apply for an induction rebate, you can get an additional $1,000 max for associated electrical infrastructure upgrades. Because as Richard touched on, a lot of times there's additional load as a result of installing induction equipment. So you apply online for this rebate. And we have step-by-step application instructions for all of our applicants to maneuver through the online application system. The rebate program's open till December 31st of this year. Yeah, you have to upload your product specifications and your price quotes with the application. Successful applicants are issued a rebate voucher that is good for 6 months or 180 days from the date the voucher is issued. That gives the applicants time to purchase and install the equipment. And then in order to get their rebate payment, they have to send us some photos and proof of payment. So successes and challenges of the program. We've actually educated slightly over 196 people, because I forgot we also did a webinar for the U.S. Green Building Council Central Pennsylvania chapter that I used to be director of. So we've reached probably about 220 people in round 1. So today is our first webinar that we're doing to promote CHEC in round 2. We inspired the West Penn Power Sustainable Energy Fund in Pennsylvania to invest $55,000 on induction cooking programs and projects in Pennsylvania as a result of our induction cooking workshop led by Chef Galarza at Reform Cafe at State College. We've received the most interest from K-12 schools, which I was really surprised about, but 10 of our 12 applicants thus far have been from K-12 schools. As of today, I just checked prior to this webinar, we've issued only 3 rebates. So there's 10 vouchers out there, 3 of which have actually been redeemed and paid. So we're still working to educate and market this program. I think a big part of this, I don't have a ton of bandwidth to be marketing this myself, and that's why I'm super excited to have a new staff person on board who's going to be helping me to market this program in Pennsylvania, and also Chef Galarza helps us market as well. I found out about Chef at Greenbuild, the U.S. Green Building Council's annual conference and expo in 2021 when it was hosted in San Diego, and he inspired me to create this program. So, and I know that Richard inspired Chef. So there's tons of inspiration going on here today, and I hope that all of you are inspired as well. But I do feel, I know that Chef has told me that as far as he is aware, and he travels the country speaking on commercial kitchen electrification, as far as he's aware, this is the only state-led program to incentivize all electric energy efficient kitchens. And maybe we were a little too soon out of the gates. Yeah, so spread the word if you can about this program. And so it's a reason why we've opened the program up to restaurants in round 2 and increased the rebate amounts is simply because we didn't see enough appetite out there in round 1. So here is a link to our CHEC webpage where you can find our rebate program guidelines. They're only 8 pages long, including the cover pages. We kept them real concise. This is not a grant program, it's a rebate program. And all of our induction cooking workshops and recorded webinars are also on that page. And we also have an email distribution list you can be added to. And then finally, here's my direct contact information if anyone wants to get in touch. Thank you, Joe.
Thanks so much, Heidi. Yeah, the question of whether too soon, we always need leaders. So we appreciate Pennsylvania taking the lead on this rebate program. Do you think education will help increase the appetite in the rebate program? Is that the hope that the more people know about it, the more they'll try to transition to all electric kitchens?
Definitely. I mean, I modeled this program off of our PADEP agricultural energy efficiency rebate program that we have. And that's just a rebate program. There's no education with it on how farmers can become more energy efficient. So with the commercial kitchen electrification, we knew going in that it's a newer technology and folks need to learn about why they don't have to be so connected with their gas and attached to gas cooktops, that really induction cooking is the best way to go for your health, for the environment, and for cost savings.
Thanks. Liepa, anything you were seeing in the chat for Heidi?
Yeah, someone asked if the $1,000 max incentive for panel upgrades is based on actual costs.
It's not. We the one rebate program that we looked at going in for commercial kitchen electrification is SMUD's program out in California, Sacramento Municipal Utility District. So Chef, when we were designing this program, Chef showed me SMUD's program, and I sort of modeled ours a little bit off of theirs. So it's only potentially a fraction of what might be needed. We've only gotten 2 induction rebate applications, and those folks have yet to install their equipment. They're in the process of doing that. It's an assisted living facility and a K-12 school district in the Philadelphia area. So we're really anxious for them to get that equipment installed and highlight them and praise them in our social media.
Great, thanks, Heidi. I encourage you to check out the chat. Melissa just put a comment on the potential of offering upstream rebates and how that might help marketing to distributors and such. But let's turn it over to Chef Chris for the final presentation, then we'll bring Heidi and Richard back on for the final Q&A. So thank you so much, Heidi.
Sure thing.
All right, friends, can you hear me?
Yeah, sounds great.
Okay, perfect. So so my name is Chef Chris Galarza. I'm the founder of Forward Dining Solutions, and I'm really excited to be here to talk with you all, especially with the company that I'm with. So we heard a lot about what induction cooking is. Let's talk about how induction cooking affects the life of a chef. So first and foremost, I want to thank Richard and his team, because a lot of the numbers I'm going to cite came directly from their lab. He wasn't kidding when he said that they were the leaders of collecting this data. They are awesome, and they are one of 2 labs, one of which is also in Southern California, Edison. Shout out to Dave in the chat. Those 2 are really leading the way for us collecting all of this data. So when we talk about the traditional gas stoves, a lot of people think that gas is king. You can't cook without gas. It's the most efficient thing out there. The truth is, it's really not. Right. So for this heavyweight bout, we're going to say that this gas stove is 50% efficient, which I haven't seen one, but it might exist. Truth be told, they're really around 35%. And from my conversations with Richard, it seems that in the hands of a professional like myself, it's actually not that good. We're somewhere in the high teens, low 20s. So assuming a 50% efficient gas range, we can cook 38.6 pounds of food per hour. Now, if you haven't taken the time to clean one of these things after a long night of cooking, you should know it's going to take you about 20, 30 minutes to really break that thing down, really scrub it down good, and really use the heavy degreasers and all these things, which is going to cost you money. It's going to cost you time. It's going to at times cause burns or fires. It's happened to me. It's happened to everyone that I know. But that's the reality of cooking with a gas range. Now, conversely, an induction range, we're talking 90+% efficient, which means we can cook 70.9 pounds of food per hour, nearly doubling the throughput of a traditional gas appliance. It's a lot easier to clean. Hot soapy water is all you need. So now you're saving on chemical purchasing costs. It's going to take you about 60 seconds to clean this, which is going to save you dramatically in labor costs. And it's a lot safer to use. There's no thermal sources of heat. So you spill some cream, you wipe it off, you move on, right? So imagine a kitchen. Now you're not purchasing chemicals, right? Now you're saving about 30 minutes off cleanup time with your staff. And imagine a staff, say 30 daily, weekly, monthly, quarterly, yearly. You can see how the savings can add up really quickly. Now we talk about efficiency, but what does that actually mean to a chef? What that means is the amount of food, the amount of energy coming in contact with the food, and how we're able to cook the food. So we talked about how much food we can cook, but why is that? Well, that's because a 30,000 BTU range is only getting about 10,000 BTUs to the food. With that induction, we're getting a minimum of 14,000 BTUs to the food. So now you can see how much energy is actually getting to the food. We're cooking things faster, turning pans over. But there's also the conversation about woks, right? People think that the gas wok is king, and truth be told, that 100,000 BTU wok is only getting about 20,000 BTUs to the food. Now you can see a 3.5 kilowatt and a 5 kilowatt isn't quite there yet, but those are countertop versions that you can have in your home. The one that's really comparable is that 12 kilowatt, where you can see 35,000 BTUs to the food. So that wok that we have installed in Microsoft, they're not even going past half power. They're cooking about 10,000 meals a day, and they're not even coming near what they can actually do. So it's far exceeding the production that you need, as well as saving you water. That wok can save you about 500,000 gallons of water per year per wok, which is significant savings, especially if you're out in the West Coast where water is as good as gold. So another analysis done by Richard Seam was the cost of energy. He talked about that study. I wanted to kind of showcase that study because I thought it was really, really impressive to see those numbers. And the analysis was making the assumption that you were operating your restaurant for 360 days a year for 15 hours a day. You were paying about $1 per therm or 17 cents per kilowatt hour. So a therm is 100,000 BTUs. If you were to do that, your gas range would cost you $1,123 a year to operate. If you were to do that with induction, that's 17 cents per kilowatt hour, $1,114 a year to operate. Now, what isn't talked about is that gas, the cost of gas has been fluctuating. In 2021, it was up, I think, like 67%. 2022, it was down only 7%. And you can see that wild fluctuation is causing those mom and pop restaurants a lot of heartache. You heard news stories at the LA Times earlier this year about restaurants getting $8,000 gas bill. Gas is kind of all over the place. Electricity has been a widely stable fuel source. And also, just to touch on potential cost savings, this is one that we're not going to be able to get into, but I just really wanted to highlight is that the constant flow hood system, or the gray, is using 100% of the power all day long, right? And this was actually data taken from my kitchen in Chatham, where our hood system would have cost $100,000, but we went with one that was way more, 3 times more, because it was going to work with the geothermal wells. It had heat recovery, had all these things, all the bells and whistles. And why that's important is because people oftentimes get scared by the sticker cost, right? But it's the operating cost you really should be looking at, because you can see by the blue line, it was ramping up and down based on our usage. And why that's important is that we were able to pay off that unit through energy efficiency alone in 9 months, which means we were saving about $100,000 a quarter just by using the equipment as efficiently as possible. Not saying this is going to be the result that everyone gets. We had best case scenario with geothermal wells and all these things, but it's still, the potential savings is insane, and it's out there. Now, thermal comfort is a big deal that doesn't often get talked about. Thermal comfort is traditionally broken down to 3 things, right? Mother Nature or air velocity and the humidity. You, as what the building owner can control, right? What's the temperature you set on the thermostat? What sort of equipment did you put into your building, and what sort of radiant energy is it putting out? And you, as an individual, what are you wearing, and what's the level of activity that you're doing? All of that contributes to thermal comfort. Now, ASHRAE did a study where they tested over 100 kitchens for a week between summer and winter comparisons, all different climate zones. That the first thing they found is that the optimal thermal comfort range was between 68 to 82 degrees Fahrenheit, depending on the level of humidity. Now, the only time a kitchen was comfortable is when they were prepping or cleaning. For the most part, when they were cooking, you can see how hot the kitchen got, even one way out here past 100. Now, what does that look like being the guy in the white coat? Well, this is what people think of, flashy, it's cool, we're having a good time, there's flames everywhere. The truth is, it's a really uncomfortable environment. We are working as fast as we can. We're running with hot things, with knives. We have things that can cut us or burn us or maim us or send us to the hospital at any given moment. And we're doing everything we can to keep up with the production necessary to make you all happy. What's not talked about, it's talked about in some books. If you read Kitchen Confidentials, Chef Anthony Bourdain talked about this back in 2000. But I remember one time personally looking down at my thermometer, my chef coat, and it read 135 degrees Fahrenheit. Now, I'm not a runner, but I can tell you that when you're running at that pace for constantly, right, trying to keep up with everything, your body fights back. And what we would see is that some of us would be keeled over between rushes, throwing up, running to the bathroom, whatever the case is, because again, our bodies are fighting us. But it doesn't have to be that way. In fact, the kitchen of the future, as Richard so eloquently put, is one that's much cooler, much more comfortable, has more natural light, is faster, it's more efficient. You can work with less people. You're able to keep up with production, to keep up with the crippling demand of our consumers, while also being good stewards to the planet. Now, again, to further reiterate my point, here's actual data. So this is data from my kitchen that was taken between September 9th and September 2016 to 2019. You can look it up. It's in Gibsonia, Pennsylvania. This is where the outside temperature was anywhere from 85 to 90 degrees Fahrenheit, which was the optimum, which is like what we would consider the perfect summer week. And what you would see here is the entire week between production, cooking, cleaning, the whole nine, we never hit 74 degrees Fahrenheit. In fact, we averaged around 70. So that means we had an over 60-degree drop from a traditional kitchen, the kitchen that I kind of grew up in, versus the kitchen of the future. It's a big difference. Now, we couldn't get into everything, but I did want to kind of break down further those benefits of electrifying. There's going to be, excuse me, my dog really wants to go play. There's a reduction in idling equipment. There's a reduction in the building emissions, which is going to reduce overall environmental impact. It's also going to operate more efficiently, which is going to save you energy and utility costs. There's going to use precision cooking controls, dramatic improvement in thermal comfort, as we just talked about. It's going to extend the life of your pots and pans. Another thing folks don't really talk about often is that the pots and pans that Heidi saw at Chatham that we have had for almost 10 years now looks pretty much brand new. You don't have to swap them out every couple of years or have the soot build up or the pan's all warped and won't sit right on the range. That's a thing of the past. It's easier to clean, which is going to save you on chemical costs and labor costs. There's fast throughput, which means there's an increase in productivity or the dollar per labor hour is improved. And finally, improved air quality, which is a really, really big thing that doesn't get talked often enough. But if you come to our August 15th webinar, we will break that down even further. Now, some myth busting. We're going to make it have some fun here as I grab my dog. So myth busting. So these are real things that I've heard from chefs in the industry. And one of the first and most pervasive myths out there is that you can't produce quality food on induction. Now, that's not true, as a fat duck and Noma has attested to. In fact, Noma was the #1 restaurant in the world. 165 Bistro, a Michelin star restaurant in San Francisco, is all electric, as well as R3 Rosendale Concepts, which is opened and operated by my old boss, certified master chef Rich Rosendale, which is also Atlanta's first all electric and ventless restaurant. And more importantly, the Olympics and the Bocuse d'Or, two of the most prestigious culinary competitions in the world, are all electric. In fact, every international culinary competition in the world is all electric, making it the preferred choice for the best chefs on the planet. Now, more of these myths are that cooking speeds are exaggerated. We just showed the science as to why, thanks to Richard Steen. He said the sauteing isn't possible on induction. This is a personal favorite of mine because the chef said that once you lift the pan off the surface, it's not connected. Therefore, it cannot be, it can't stay hot. And I had to really explain to the chef that once you lift the pan up the burner, the flame doesn't follow the pan to keep the metal hot. It's the same principles apply. The metal's hot. It's just, you're only picking it up for a second. But yes, sauteing is possible. And then they said that you can't preheat your pans, which is, you don't really have to. In fact, if you watch the PBS documentary that we were just featured in, I took a pan out of the freezer filled with ice. I dumped the contents, tossed vegetables in, and started sauteing immediately. From a frozen pan to sauteing within seconds, you don't have to preheat your pan. Okay. The theater of gas gives people the false perception that it gives you more control. The truth is it doesn't. You just kind of see the size of the flame and assume you have control. So I can guarantee you, if I ask you if your flame's on high, you have a pan on it, what's the temperature of the pan? You'd have no idea. But if I were to say, set my pan to 325 degrees, it'd be exactly within 1 degree, 325 degrees. Induction cooking technology does not accommodate wok cooking. Not true. We couldn't go too far into it, but Richard talked about it. We talked about the data behind that. It absolutely does. In fact, a friend of ours, Martin Yen, I'm saying friend of ours, is actually a friend of Rochelle Boucher, someone who Richard and I know quite well. He's been a huge supporter of induction cooking and says that the newest restaurants coming into Beijing are all electric, and they're using electric woks. And finally, the glass surfaces are going to break. Chefs are big, tough people. Kitchens are really big, tough places. There's no way that glass is going to hold up to the conditions of a professional kitchen. And truth be told, that's not true. The truth is that they use tempered ceramic glass, which is far stronger than anything that we would consider using in a kitchen. Typical tempered glass can withstand temperatures of up to 600 degrees Fahrenheit, where tempered ceramic glass can withstand temperatures far exceeding 1400 degrees Fahrenheit. And there's nothing in the kitchen that's going to get that hot. You'd have to take a sledgehammer and really try to crack that thing to make that thing break. Now, let's go into a case study of my old stomping grounds, Chatham University, Eden Hall. It was built by Methuen. This place was a chef's playground. I had my own farm. We raised our own trout, even in this building over here. We built America's first all-electric campus kitchen. Or really, we built America's first all-electric campus kitchen, but we also built the world's first fully self-sustained university campus. That's what made this campus so special. Now, the average EUI, or the energy use intensity of a kitchen, is about 325. I'm not going to go through all the different strategies we went through, just to know that as we continue to have conversations, it would model down to 233, and then eventually down to 162. And after a lot of discussion, we did eventually settle at 121. Now, that was before renewables, and that was before this canopy was built that eventually made the campus net zero ready. But in actual in application, and full disclosure, we weren't full with students at the time, but we did get our EUI down to 52, which is far less than they expected. We were creating more energy than expected as well. And we go into far more detail in the decarbonization guide that we co-authored with the William J. Worthen Foundation. And if you want to read up on that, please go to my website, forwarddiningsolutions.com. Under the resource tab, there'll be a link that'll send you to download this guide. Chapter 5 specifically talks about kitchens, but this is the most robust, most comprehensive guide ever written on the subject of building decarbonization, and is again 100% for free. And finally, if anyone out there is interested, I'm partnering with PSE and Richard's team as well to conduct a study on commercial kitchens and the air quality, or rather the exposure rates of hospitality workers. We're hoping to launch the study sometime next year. But if anyone is interested in signing up, we will be paying restaurants, we will be paying kitchens to allow us into their space. Feel free to sign up with the email below, or go to my website as well. There's a tab that'll take you to the sign up page. And then once we are ready to kind of start contacting people, you will be on the list. And with that, thank you.
Yep, Chris, thanks so much for that. I was in real time, I was seeing questions come in, and then you were answering the questions.
That's awesome.
Are the induction stoves durable? Yes, they're durable. That's really great. I'd encourage the other panelists to come on camera as well. And Chef, if you want to stop sharing, we'll do some Q&A here. I think first question for you though, Chef Chris. What do you say to the chefs that are kind of wedded to gas? And you've listed a lot of the reasons, but how have you found success breaking through to chefs that like to?
That's a great question. To be honest with you, it's just meeting them where they are. Chefs tend to be very tribal. They're very protective of their space. But if you just kind of go there and say, hey, I'm just trying to figure out how to make things better for you, like it's easier for me. Like I'm not an architect, right? But I could come in and say, hey, we're on the same page. Here's my resume. We can respect each other. Let's talk. And we're able to kind of break through all those barriers and just say, what are you afraid of? And then we tackle them one by one. And once their excuses or as I've called it, myths kind of get answered, we can start having a conversation of how is this going to benefit your restaurants. I can go there and spout numbers all day long, but if their concern is I'm going to break the glass, okay, well, let's talk about that. So we kind of let them kind of lead the conversation. We answer them, and then once we get them to understand that the anxieties are going away, we can start getting them excited. And I'm happy to say that I have not had a chef say no yet. Knock on wood.
And Joe, I answered that question online as well. I've been furiously typing answers as Chris was going, but one of my suggestions is to get the chefs, whoever that chef is, to one of the centers, like our facility, the Food Service Technology Center up in Northern California, or Chris mentioned Andre's facility down SoCal Edison, and get their hands on the equipment. We had Chef George Chin came in to try out the induction wok, and he owns, he's a famous chef, and he owns a very popular restaurant, and he's got a project that has to be all electric. And he brought some of his food. We fired up the wok. The manufacturer was there. He did some tests, and he said, yeah, I can make this work. I'll have to play around with my recipes a little bit. I can't do this thing that I kind of do by habit, but I can work around that. But otherwise, this will work, And we say hands-on changes hearts and minds. So get their hands 100%. On it. Yeah.
And
chefs are kinetic learners.
We are, yeah.
We've definitely witnessed that at the induction cooking workshops through the CHECK program, that a chef actually allows attendees at our most recent one at Swarthmore College. Chef allowed the attendees to actually cook on the equipment. And that was really eye-opening for them. And then also, what was also eye-opening was that the chef that was cooking from Swarthmore turned off his induction cooktop when he was done. And they're like, wait, you can just turn that off? Don't you need it still today? And they're like, we have to keep this equipment on all the time in our kitchens. We can't just turn it off. It's fired up. We got to keep it fired up. So talk about energy savings.
Yeah.
And reduced emissions.
Yeah, it was powerful stuff.
Heat savings, all the benefits of that. Liepa, do you have a question on deck?
Yeah, this is for Richard or anyone else who wants to chime in. Can you talk about the policy landscape of the electric kitchen requirements or electric readiness requirements in California or beyond?
Yeah, like I say, I think it was 2014 or 2015 when I went to the NBI conference in Denver. One of you NBI veterans can remind me. The Getting to Zero conference, and and this is where people first said, hey, we're not moving the needle fast enough, expect to see codes and standards. And very shortly thereafter, people started working on, municipalities in particular started working on all electric reach codes, is what they're called. These go above and beyond. And various cities. I believe we're up to 104 municipalities, something like that, 105, and the numbers they're going up and down. With Berkeley being the first city, right? And so municipalities, their city councils say this is what we want to do. Different cities took different approaches. In Berkeley, they said all new and mostly it's new construction, right? They said all new construction will be all electric. But they did allow those first couple of years, they allowed you to build electric ready restaurants, still maintain your gas. If you already had a permit in process, right? There was a little time there. Same thing in San Francisco. There was a little delay time between the time they pass and the time they expect things to happen. You know, it's not completely shotgun. They're thinking about these situations. Now, somebody had mentioned the Ninth Circuit Court. The California Restaurant Association came back and sued Berkeley and said, you know, we don't think this is a great idea. And the Ninth Circuit issued an opinion, which is not a ruling, but an opinion that shut down the Berkeley electrification ordinance. But you know, there were only 25 other municipalities that had mirrored the Berkeley ordinance, so it didn't affect the other, you know, 75 plus folks out there. And if you had a building code, you can actually come back. That opinion was pretty narrowly defined. It's kind of potentially open to appeal. So, but a city like Berkeley could come back and say, sure, you know, we won't require you to be all electric. We'll let you be electric ready. And, you know, you have to put in all the infrastructure for the electric side, you know, and you can use your gas for however 5 years or something. But if you're a developer and you're looking at your capital cost of building an already very expensive facility, and you know you have to put in all of the infrastructure for the all electric, why would you go and put in the gas infrastructure as well? You know, so when people start talking about like the states that are doing the ban kind of thing, great, go and ban the ban, you know, but what'll happen is the municipality will say, sure, you'll have to be all electric ready. And from a capital standpoint, you'll be like, well, hell, I'll just go all electric. Why bother, if that makes sense to you, right? That's the way to get around that. And you can do that in your building codes.
Yeah, and if I can jump in, that ruling was very specific to a very specific rule that they were kind of trying to play around with.
Mhm.
But Berkeley did it too, like both ways. They did it with building codes as well, which has already been litigated to death, and there's no way around it. So there's no way to ban the ban or whatever the case is that these people are talking about. It's very, very set in stone that these building codes are the way it is. And what's been exciting is that we are only 3 years from when, or I guess now 4 years since they initially passed that ordinance. And to go from one city to, no offense, Heidi, over 100 cities, government isn't known for working that fast, right? Except for Heidi, she works so fast, it's not even but the truth is that it's really taking, it's showing that it's not a trend. It's more of a sustained, pardon the pun, it's a sustained burn. This is going to be a thing that is not, it's not an if, but rather a when. This is going to be national at some point.
Yeah, but having said all that, as I mentioned earlier, I'm a lover of food, and I am a proponent of municipalities and policymakers taking into account their small business people in their city. Mm-hmm. And I actually testified the night that they passed the Berkeley ordinance, and that's one of the things I said. This is all technically doable, but you know, if you want a pizza restaurant or a bakery, you're going to make it very hard for them. So I urge cities to, as they pass these things, to think about what they can give back to the operators. So if Richardville requires you to be all electric, you know, maybe I can give you back a super fast permitting process. Hey, I'm going to get you permitted in 4 weeks. I'm going to push you to the front of the line and save you money, right? And the same thing, utilities need to be thinking about what kind of rates they carve out for food service. But food service is a different industry, and we need to walk a little gently as we do this. It's all is a challenge, yeah.
Such as the check rebate program.
I was going to say,
yeah, or the rebate programs, right?
Exactly. And
Yeah.
I do want to add one thing about that program, is that what makes that program so special is that it's not just about saying, here's a check, move on. It's really thoughtfully put together to help you understand what you're doing so you can design your space with purpose and connect you with experts that can help you get to where you need to be. So it's not just blindly here's the money. Like it's about education and the rebate program, and it's about giving you the option in a state that like most states are just trying to push one way or another. Pennsylvania is just saying, here's the option. If you want to do it, it's there, but we're not going to force you. And I really like that approach. It's and I think that's what makes this program, to me, far and away the leader in what other states should be doing.
Thanks, Chef. And I will say that I forget where I was going to go with that. I'm sorry.
Well,
I'll think of it in a second.
A lot of praise to the CHECK program. And do you see this as the carrot to help eventual sticks in Pennsylvania, Heidi? Are you seeing any of the electrification movements there?
You mean for other than commercial kitchens, or?
Yeah, just general electrification mandates.
Not mandates, but one of the reasons why I haven't had a lot of time for marketing this program that I created is because I'm in charge of the IRA home energy rebates for Pennsylvania. So that is just a ton of work.
Yeah.
And it's the most funding that our energy office has ever received in its history. Yeah. So
the induction rebates will be for the homes rebate.
For homeowners, can get induction rebates. Yep. As well as energy efficiency, heat pump water heaters. So that's been taking up a lot of my brain space lately. So.
And if I could also add that, like, Pennsylvania is the #2 producer state of natural gas. So if this can be done in Pennsylvania, for all the policy people out there, what's your excuse?
That's right. Well, that's perfect. Well, I do want to switch gears because I think the most popular question we got today was on the panel upsizing.
Panel sizing.
Yeah, you saw that in the chat too, Richard. I mean, I think Keith put it well, so maybe I'll turn it over to you. Keith said a typical 2,000 square foot restaurant, which uses both gas and electric equipment, can get by with a 200 amp 3-phase service. What's the comparable electric panel size for an all electric kitchen? Is it 400 amps?
Yeah, it just really depends on what the equipment spec is. Are you a Starbucks or are you a burger joint? How much energy intensity do you have in that space is what will drive the panel sizing. So it's one where I don't have a good rule of thumb. And to date, we have, this is one of the things that's on our R&D wish list, is to go out and do a really good survey of a bunch of restaurants and try to find, existing equipment panel size and panel surplus, as it were. If I wanted to add something, how much power would I have? But that bigger survey doesn't exist. And like how Chef Chris showed you the survey of the heat that we did for ASHRAE, that one, that's out there. That makes sense. We need to kind of do a panel sizing R&D. But once again, it really depends on the equipment. And same thing, what you did with your mixed fuel restaurant, you may do in the same square footage, you may do something completely different with your all electric restaurant. You may get rid of the broiler and put in another combi, right? So you don't want to try and design a 1-for-1. So it really is, what's your kitchen, what's your loads? Now let's go back and see what we can do. And in the future, there are going to be smart breakers, and there's a system that we talked to some folks about called Cicatronics that's actually sitting there and kind of leveling your loads for you. Once again, it's essentially artificial intelligence that is looking at your loads and keeping your breaker sizes down. I'm electrical engineer, right? Lord knows we love to over design the hell out of everything, and that's for safety reasons. But we still, all of our electric codes are still based on the notion that it's a completely dumb grid, and that we have to have breaker sizing that essentially matches up to whatever our load is, with some numbers for diversity. But as we start getting into artificial intelligence, there's no reason to have, it's like owning a pickup truck, or a dump truck to drive down the local 7-Eleven. We over design everything in our grid. As we get some artificial intelligence and smarts in the system, and we can back that up with physical components that keep the system safe, we'll need a smaller system. We don't need all of the wires we have now because they're just oversized. It's 1940s design, really.
Yeah. Not to mention the induction stoves with the battery backups that are coming on the market. Will there be that?
Exactly. And you're going to see that. You'll see some more battery backup on, on say quick service restaurants. And that'll be good because, hey, that'll help them balance their loads. I mean, we didn't talk about the other elephant in the room, which is peak demand. When we go all electric, we're now going to run into peak demand issues. Now, the good news is it used to be peak demand for restaurants was at noon, and it killed. Noon is lunch. That's when you're making your money. So you were paying the most power, then. Now out here in California, we actually are throwing away energy on a hot day like today. We're throwing away energy because we can't store it fast enough, right? So the peak goes below zero at lunchtime now. Our challenge now is dinner time. But battery storage makes a lot of sense. Plus, when we start talking about, that the other elephant in the room, climate change, which hugely affects the food service world. In California, these fires have meant that the utilities have to do power shutdowns. If we can get some local storage, and your grid goes down for 15 minutes, maybe you can run off your battery storage, right? Instead of trying to hook up a generator outside the facility. So yeah, that's that notion of the grid of the future. I mean, the number one thing I hear from the folks who are real naysayers is, how will we build a grid? Where will we put it? And the number one thing I have to come back and say is energy efficiency and technology will help us to levelize that so we don't need to double the size of the grid.
And touching on electrical panels and the additional loads with induction, I mean, that has been a challenge. I know that one of our K-12 school districts that wanted to apply for CHEC, she was our CHEC cheerleader, like came to Chef's Workshop at Swarthmore and really wanted to apply. And she got me into a School Nutrition Association food conference next week that I'm going to be in their expo hall for, promoting the CHEC program. So she was awesome and she really wanted to do induction, but she met with her school electrician and she just couldn't speak that language. That Richard so well speaks. And that's why I'm so glad my new staff person, he's an electrical engineer, just like yourself, Richard. So he can speak that language. And we need that kind of support to these entities that want to go induction. And in addition, the other thing that we found that they need help with is product selection. They really don't know, like, it's new technology to them. What should I buy out of all this equipment? Like, what's the best? And I'm government, so I can't recommend any particular brand. But I turn them over to Chef Galarza, and then Chef Galarza also works with another chef in Cherry Hill, New Jersey, called Chef Norbert, who connects directly with manufacturers to get that equipment. So it's been a great partnership with Chef Galarza, and then over to Chef Norbert, who helps us with product selection.
And if I can say that, stay tuned, because we are working on something that'll help standardize how equipment's selected. We'll be announcing more on that probably on LinkedIn and things like that once it's ready. But there is stuff in the works to help everybody out.
Oh, that'd be a great resource. Yeah, let us know when that's ready. We can send it out to all attendees.
Sure.
Go ahead, Liepa.
Yeah, I have one more question that someone put in the chat. On the point of relative efficiencies, the 35% versus 90% figures are just the equipment efficiencies, correct? If they don't take into account idle time and the resulting energy losses from gas equipment, would you say that the overall system efficiency is even less?
That's absolutely correct. And Chef Chris made mention of that. So those numbers are our laboratory numbers. And the way we measure that is we put energy into the device, like once again, $1 worth of energy into the device, and then we measure how much energy makes it into the food that you're cooking. And we have very strict test methods we've been developing for 35 years. They're all ASTM standard test methods. We develop them, then they get ratified by the industry. But they are under the best conditions, like laboratory conditions. When you get out into the field, once again, as Chef Chris mentioned, on the induction cooktop, that efficiency number will stay pretty much the same, because when you remove the pot off of the induction cooktop, it draws no more energy. It cuts itself off automatically. On the gas range top, I move something off, the flames are still going. And as Chris has seen many times and alluded to, you have a saute line, you have all the burners on. A lot of times you're heating up the pans with nothing in them, and you take the pans off, the flames are going. So yes, the usage efficiency of a gas range top will fall off pretty dramatically depending on how it's used. In a school district, it'll probably still be pretty high, but in, you know, Chris's full service restaurant, it might fall down to 10 cent to 10%, which means that you bought $1 worth of energy and you did 10 cents worth of work with it.
Hmm.
And the same is true for all of these appliances. You know, a fryer is, you know, if it sits there all day, and or an oven, it sits there for hours with nobody using it, its efficiency will drop down.
Thanks. Well, I did want to maybe last final question, because we're running up on time here, but in 30 seconds to a minute, if I'd love to go around and let us know what's next for your work. Chef Chris, you identified one piece, the assistance with helping choose equipment. What's next in your work, or in electric, all electric kitchens in general? And Chef Chris will pick
Sure.
on you.
Yeah, so we are doing, I'm trying to be careful what I can say, but we are working on something very big that's going to standardize how kitchens are designed, built, and operated in the future. But you know, I would encourage anyone to follow me on LinkedIn, where I'm most active, where we have newsletters, where we have weekly kind of information going out, educating about what electrification is, how does it compare, you know, to our traditional counterparts, like what's in the eyes of a chef, how is it beneficial, and how does it compare as far as in the big picture, you know, to climate change. But we are doing a lot of work with Heidi. We're doing a lot of work nationwide, where we are educating. We're doing workshops, we're webinars. We are going to be in as many conferences as possible. So we will be out there, but please feel free to reach out if there's anything we can do to support and help you in your work. We just want to see these kitchens get built and built right. In the kitchen, we have a saying, do it right or do it twice. We want to help you do it right.
Love it. Love it. Thanks so much. Heidi, we'll turn it over to you next. You identified a little bit of what's next in the round 2 of the programs, but what anything to add to that?
Yeah, I mean, because we made restaurants eligible in round 2, I'm really excited to focus on promoting this program to restaurants and seeing what the appetite is. And one of those main reasons is just a really brief story from our first induction cooking workshop with chef at Chatham Eden Hall in March of this year. 2 chefs attended from a small business, a restaurant in Pittsburgh. And one of those chefs told me the story that just a few days before our workshop, he was rushed to the hospital. He had worked over a multi-burner natural gas range, 6 to 8 burner range for his 8-hour shift. And he went to the bathroom after his shift and couldn't get up. And when they took him to the hospital, he had suffered from severe dehydration and heat exhaustion. So health benefits to the chefs in these restaurants. I mean, I really want to try to promote that benefit, and we'll see how it goes. But we have a great story to tell here with the reasons why folks should be going induction in Pennsylvania.
Thanks so much, Heidi, for that. Yeah, powerful anecdote. That really drives the point home. Yeah, Richard, we'll finish with you.
Yeah, we're sort of always marching forward. So we continue to test a bunch of appliances and add them to that rebate list, the California Energy Wise rebate list, which once again, I say, if you're looking for equipment, even if you're out of California, use that as your master list. There's 3,500 pieces on there. We're going to continue to work on the induction wok challenges, try and working with manufacturers and get that equipment in. Same thing, building up our demo kitchen for more high-tech equipment and working on the kitchen of the future and trying to model all that kind of good stuff out. And we're also, if you are in Chicago area, we're working on a program with ComEd that's going to be similar to Heidi's program. So if you are thinking about purchasing some electric equipment, there will be some rebates, there will be some design assistance, some education. So email me if you're somebody in that area, university, school, whoever who's thinking about changing over, and we'll get you in the pipeline. So yeah.
That's exciting. Thanks so much. Thanks. Huge thanks to all of you for joining us today. Thanks to our panelists, Chef Chris, Heidi, and Richard. Huge thanks to Liepa, Soraya, and Susan and the NBI team. We will be back in October for our next manufacturer roundtable on heat pump water heater, residential heat pump water heaters. And we're also working on a fact sheet for all electric commercial kitchens, so we'll send it out to registrants of this event. Thanks so much for joining us.
If I
Chris,
can just
go ahead.
add one more thing I just thought
Yeah.
of. I'm always looking for help. So if anyone out there is interested, I am in the middle of developing a curriculum and currently writing a textbook on the green industrial revolution with a focus of the hospitality industry. So I'd love input if anyone's interested in partnering with us to support this work.
Yeah, count me in for that, Chris, but absolutely.
Awesome, for sure.
Thanks for that. Huge thanks to everyone for joining today for this fantastic webinar. We will send out slides and recording as quickly as can at the latest tomorrow. So have a great rest of your day, and we'll see y'all soon.
Take care, everybody.
Thanks for the opportunity. Bye.